For our project, our main goal was to improve an LLM. So we chose GPT-2 since it's already a popular LLM by OpenAI, and our goal was to, as I stated, to improve it and to refine it. We thought music was important because music is something that's appreciated by everyone, and sometimes there are barriers to creativity, and through using AI and LLMs, we could help assist these artists in creating new content for others around to enjoy. To improve on GPT-2, we focused on one main dataset. That dataset was a large collection of song information from Hugging Face, and we will link the creator of that dataset. And the reason why we chose this specific dataset was because of the vast amount of songs and wide variety of songs. There's genres from like rap, pop, country, and this allows us to really encapsulate all different types of music that is out there. It allows our program to be used for different song types.
Okay, now time for the code walkthrough. So initially we load in the data set from the one we found on Hugging Face. It has a few million songs on it, so we specify our subset for however large we want to train, generally overnight because it takes several hours. Then we load in from a pre-trained model, either the one that we have been training this whole time or the base GPT-2 model from Hugging Face. It uses the small GPT-2, which is like 124 million parameters. Then we tokenize the entire data set so that we can run it through the model for text generation. Then we set our fine-tuning parameters and create our data loader to run it through the model, and we train it on GPU if we have it available. On Kaggle, they give us free GPUs to use, which significantly speeds up the process of training. Then we save our outputs, and to run it through the model, we run it through a pipeline, which just tokenizes and then runs it through and then gives us the output. So we give it a prompt, and then it gives us lyrics, and they generally are significantly better than the base GPT-2 lyrics, which a lot of the times will just output complete nonsense. So at least we get like lyrics to an actual song that seems to be good. Then for objective evaluation, we first use perplexity, which is like how sure the model is for each word that it produced. So it just runs it through like an exponential function for the loss. And we find that our fine-tuned model is significantly lower perplexity than our GPT-2 model, meaning that it's more sure of every word that it produced when prompted on a lyric to complete like the lyric generation. And then we also use our rogue score, which evaluates how similar a generated text is to its original. So we first run through our model with the original lyric, but with some of the words masked out. And then we ask it to fill in those words. And then we run it through a rogue score calculator to determine the similarity between the generated text and the original lyrics. And this led to the same performance on our fine-tune and GPT-2, though that could just be because this rogue score calculation isn't exactly for this for lyrics evaluation. We just tried to find ways that we could objectively test. But what is more important of a test is like anecdotic and
Subjective.
Yeah. A more important test is subjective, so it includes like the meanings of the lyrics and if they just sound good in general. So ideally, we could just produce 100 lyrics from 100 different prompts and then query a bunch of different people on which ones they prefer, but that's not very feasible. So instead, we run it through ChatGPT's 3.5 model, which will give us its preference between two lyrics, one of which is our fine-tune model, the other is the base GPT-2 model. And when running it through with 100 randomly generated prompts of complete the lyric type responses, we get that our model was chosen 79% of the time, showing significant improvement in lyrics generation for our fine-tuning process.
Here are some snippets from the samples of songs that we generated from our model and GPT-2 when given the same prompt. As you can see, we take these songs and we put them into ChatGPT-4 and we ask it which one it thinks it's better. And 10 out of 10 times, GPT-4 found that our song was better than GPT-2. We also found that our model was better about structuring songs. As you can see, it gives it more breaks in paragraphs and sections the songs into verses, whereas GPT-2 just gives the song in a chunk-like paragraph. Our model is also better about rhyming, and it repeats themes in lines like a chorus in a song would. And so, as you can see from this example, we find the repeat in change and change again, and then also back home again, back home again. So our model generally produces songs that are a little bit more song-like, the songs that we know and hear and see all the time. And same thing, like GPT-2 would often put random punctuation in songs that we don't really see that normally, so it's unusual punctuation. Here's another example. Our model repeats this life, it sections it into verses. And our songs tend to be a little bit more emotional than GPT-2's were, a little bit more heartfelt. Using this method of using ChatGPT-4 as a stand-in for an actual person to subjectively judge if a song is better than another one, we found that 10 out of 10 times GPT-4 preferred the song produced by our model over that produced by GPT-2. Thus, the enhanced model demonstrates a noticeable improvement in creativity and cohesiveness.
When working on this project, we ran into a lot of issues, especially surrounding the size of the data we had to work with. A lot of the times, the data sets that contain the songs were around 10 gigabytes. We were able to find some that were 5 that were easier to deal with, but that was a big problem because we couldn't really download on our computers. We had limited storage to work with. Also, handling the large volumes of data required substantial computational power. It was a big constraint for our team. The runtimes were really long, up to 9 hours. To navigate this, we used platforms like Kaggle, which gave us access to GPUs and let us do intensive computations without the need for really expensive hardware. We also used Colab, which was a cloud-based runtime, but that also gave us a lot of problems because personally, for my computer, my Colab just ran out of storage and the runtime just constantly disconnected. Let's see. These constraints forced us to be really smart about how we were going to manage our data and be really selective and creative to ensure that we could work without compromising the quality of our model training. Another key problem that we faced was the selection of our data set. It was super important that we found a big wide array of songs to train our model, but we needed to make sure that it had the specific genre specified in that data set in each song. This had a big drawback because not a lot of the data sets that were available to us had that information on it. So we might have been missing out on data that was didn't fit into a specific genre or was culturally specific. And this might have limited our model's ability to learn from a broader lyrical content that could have increased our abilities and give us better outputs. Reflecting on our project and its outcomes, there are definitely ways that we can make our lyric generation better. One significant area for improvement is the diversity of our data set. Since the model is currently trained on data sets that specifically state genre, we limited our content exposure, and because most of the data sets that were available did not specify the genre. In the future, we can explore more varied data sets that could greatly increase our model's capacity. These data sets could include songs that don't neatly fit into a category and are like underground or culturally specific. And incorporating this diversity could help our AI understand and replicate a wider array of music. Additionally, training our models on specific artists. So, like for instance, if we train it on Beyonce, we just input all of her songs, and then whenever a user wants to make a song that might be written by Beyonce, they'd specify that, and our model could generate that. This version would generate lyrics in general, but also with specific writing styles of a particular songwriter. And this approach is not only an interesting addition, but could also be appealing to aspiring musicians who want to create songs in the style of their favorite artists.
In conclusion, we have effectively fine-tuned GPT-2 using lyrical data to enhance lyric generation capabilities. This refinement has yielded a notable reduction in output perplexity, indicating enhanced coherence and predictability in generated lyrics. Additionally, our comprehensive lyric preference test utilizing GPT 3.5 demonstrated a significant improvement in the quality and appeal of generated lyrics. Our endeavor in improving GPT-2's lyric generation capabilities has not only showcased the potential of AI-driven lyric generation, but also highlighted the importance of continuous refinement and exploration in this field. As we navigate the complexities of training datasets, hardware limitations, and creative challenges, we're reminded of the possibilities that emerge for AI in creative industries when technology and human ingenuity converge. Moving forward, we're excited about the potential applications of this technology and continue to seek ways to bridge AI with human creativity.